about using GEOWEB 3 confinement for a value engineered solution. A little about myself. I've been the chief engineer at Presto for the last 18 years. Before that, I spent 18 years as a consultant working on a variety of civil geotechnical projects. I'm an active member of a couple of railroad committees, 1 and 5, as well as some ASTM, D18 soils and rock, and D35 geosynthetics. Also a member of the ISO geosynthetics committee. So I hope I can bring in both views and perspectives from my time as an engineering consultant and also my time as a manufacturer. So the purpose of today's presentation is to highlight the key benefits of using GEOWEB as a value engineering solution. So I'll share my perspective on value engineering, like I said, as both a consultant and manufacturer. Hope to gain an understanding how the system works to enhance performance. I'll talk about load support, slope and channel protection, and earth retention applications, and how to identify when it's appropriate value engineering approach. So we'll review how the system can meet project requirements, even where maybe other geosynthetics have not been looked at or considered. So if you have any questions during the presentation, just enter them in the chat and I will address them at the end. A good starting point is defining value engineering. So there are many interpretations, basically commonly understood the balance between function and cost. So trying to improve the value by either enhancing performance or reducing cost. However, it's often mistaken, especially as a manufacturer, now, as cutting costs. So in reality, value engineering should focus on maximizing value along with quality, not just minimizing costs. So it involves exploring alternative materials and methods to achieve the design's intent without compromising performance. Since cost and functionality are directly related, reducing cost at the expense of performance ultimately lowers the value. So all the project requirements must be clearly defined before proposing alternatives. So the objective is not just to meet that design intent at the lowest practical cost, but also including like life cycle costs, maintenance, to improve its functionality and quality. So when can it take place? During any phase of the project. They all have pros and cons. The planning and design phase, that's probably the best part, as we all know, because addressing it right up front, you're going to have less cost. The change is lower, the impact on the schedule is minimal. However, most of the time on projects, value engineering typically occurs after the bidding phase, at the beginning, or actually even sometimes during construction. Engineers perform their due diligence. They do all the planning, all the estimating, all the design phase, but especially what's happening around the world now with external factors often necessitate value engineering after the bid. Construction costs are rising almost daily, so it's common for the project cost estimates that the engineer made come in much higher today at the time of bidding. So this makes value engineering essential to keep the project within budget and moving forward. Engineers have a variety of tools at their disposal to meet the specific requirements, and need to report that no single solution fits every project. Each project has its site-specific conditions and goals, so evaluating all available options is very crucial. So geosynthetics, including GEOWEB, are excellent solutions to meet these challenges. So we help in creating a value engineering package that will include a full summary, a written summary. It's going to include plans, cross sections. It's going to include calculations, specifications. We do that all free of charge. So the submittal package will be consistent regardless of the project size, whether it's 10,000 square feet or 1 million square feet. So we'll work with you whatever phase you're in to make sure that our solution is the appropriate one. We work with, I think, the best worldwide distribution network out there. If we're not going to provide the most value for this project, we will hook you up with our local distributor, and they can maybe provide a more beneficial product for your project. So let's begin just a little brief discussion on GEOWEB Geocells. So Presto we worked with the Army Corps of Engineers back in the late 70s to develop the technology. We really have been at the forefront ever since. We do provide more than just product. Like I said, I just mentioned, we'll work with you from concept phase right through construction. So once we have a great distribution network, and we operate in 4 different areas: load support, slope protection, up to about 70 degrees. We can do channels, aggregate filled channels, vegetated channels, concrete filled channels. We also do reinforced slopes, gravity walls, and reinforced walls, MSE walls. We also offer porous pavements, a vegetated geoblock, aggregate geopave. And also we have some construction mats called geoterra. But today we're going to basically focus on the 4 applications I showed here. So the system consists really of 2 main attributes. The first is the cell diameter, or the size of the cell. It comes in 3 different cell diameters: 8.5, 10.5, and 18 inches. So depending on the size, we'll make sure that through that free evaluation, we'll make sure we have the correct size, and the cell depth comes in these different cell depths. Also comes in different section lengths, more appropriately to fit if you have, say, a slope project that's only a certain length. We can match the most, basically limit the waste. And we can also, if it's larger projects, we can custom make panels to a specific length also. The second attribute is a welded seam. Where basically all the internal junctions are important. That's the most important function of a geocell. The stronger the seam strength, the better performance period. So a strong seam will always make sure you lifetime performance is met. We use 100% virgin high density polyethylene resin for consistent strong welds at the seams. You want to make sure you're staying away from any products that add cheap fillers or alloys, basically to lower the cost of the product but affects the seam strength. The second characteristic of what is the infill material. There's basically 4 different types of infill. We can use coarse sand. We actually invented this GEOWEB technology for the Army Corps of Engineers. It's actually called sand grid. So the intent was to use it for beach sand that gives access to heavy military vehicles. So we can use coarse sand or anything that's a drainable sand. We can do topsoil and vegetate it. We can do aggregate, and I'll show you some testing we did. And also we can fill it with concrete for channels, for applications, retaining walls in the front face. Here you can just see a typical GEOWEB panel. It comes tri-folded on a pallet, each one a nominal about 8.5 foot width, and different section lengths. As I mentioned in the previous slide, that we can do different section lengths or custom to meet your specific project. It comes tri-folded on a pallet, ships about 100,000+ square feet on a truck, so it ships very efficiently. All of our GEOWEB, all of our accessories are 100% made in the U.S. under very strict quality QA/QC processes. We comply with the requirements to the BABA, the Build America, Buy America Infrastructure Investment and Job Act. So if you have a project with that, we can provide the necessary documentation that shows that we meet all those requirements. So the system components, those are all the supporting components that really help protect the surface. You can see we have all different types, all of these accessories, whether it's used for slope protection, where we have stakes, say, if we have our actual wall keys for wall project, 10-inch for slopes, 10-inch clips for slope protection. These are all designed specifically for the use with GEOWEB. We don't use any other outside materials. All these are engineered specifically for the use with GEOWEB. Here you can see the attribute. This is probably the most important feature and accessory that we have. It's specifically designed to connect the panels side to side and end to end. Want to make sure that you're not getting any separation over time. It might happen with, say, zip ties or metal staples. We recently upgraded. We added these frictional barbs on the bottom of the key, basically to enhance the lockup a little bit. But you want to make sure that these panels do not separate when you're putting it in. So that's what the attribute really provides, and they really provide against the 3 primary modes of basically mechanical junction failure, which are shear, splitting, and peeling. And in our calculations, we check the factors of safety of those to make sure that there's no issues with any of those failure modes. So I'll talk about the 4 different applications now. The first one is load support for both paved and unpaved roads. This is a project we did. It was about a 1.5 mile road down Energy substation. This was area south of Baton Rouge. A lot of rains, a lot of swamp areas. The initial design included about a 16-inch cross section with a couple layers of grid and a subgrade low CBR Vault 1. But when they went to put it in, the subgrade was just too weak, and with the heavy rains, the portion of the grid started to fail. So we do a lot of work with this engineer. They called us up, and we actually did a value engineered solution for them. So we worked with the engineer. We came up with a cross section consisting of an enhanced woven geotextile. These are geotextiles that can actually drain but keep the fines underneath. This one right here had about 4,800 pounds per foot of reinforcement. So a very strong geotextile. Here we had a 6-inch GEOWEB. It was actually filled with the local available sandy crushed aggregate. So we don't need to have that high quality aggregate. We can use the sandy material. We're really going to save you costs and save you time. This one, I think we reduced the aggregate by about 6,000 yards. You can imagine, cutting that cross section down to about 8 inches or cutting it in half, really saving us a significant amount of money, but also allowed them to build the road and on time and on schedule. Here you can see the panels are very flexible. They can do inside or outside curves. You basically just under or over expand them. You can see the file road construction. You can see the quality. It's not a very high quality aggregate at all. You can see the sand portions in that, but like I said, this has been serviced for a couple of years now, and they've had real no issues on it. So we knew that's the kind of application we do a lot for unpaved roads. Is it comes in low subgrade CBRs, 2, 3, less than 3, really bad soils. That's where we can really shine. This is an intermodal yard we did for CSX. It's out in South Carolina. You can see the picture. There's a heavy reach stacker, about 60 tons. It was severely rutting this area. You can see the rutting here. So you get a little better close up. It's basically the tire, but they had graders on this thing a lot. I mean, they basically can imagine every time they hauled one of the containers, they'd be rutting this. So they really is screwing up a time in maintenance, a lot of costs, a lot of slowdowns. They contacted us. We do a lot of work with them on the rail. So we worked with the engineer and the geotech on this one. And it was basically the same type of solution for that last project. We once again used an enhanced woven geotextile, a little stronger on this one. We still use the 6-inch GEOWEB. But the interesting part of this project is that during the review stage with the engineer and the geotech, it was determined that we could reuse the fines for less than about 10 to 11%. Usually if it's less than 15%, we can use it to fill the GEOWEB. So rule of thumb, if you have 15% fines or less, that's a really good infill for GEOWEB. So what we did is we just stockpiled it all on the site here, and we put it right back into the GEOWEB and used it as the infill material. Saved them over about 3,000 yards. Hauling that bad stuff out, hauling the good stuff back in. Just the downtime and how much speed, so it really saved them a significant amount of money. And you can see just the final solution, a sandy, low-grade sandy aggregate. This is held up. They maintain it maybe once a month, if that. So just sometimes after heavy rains, because there is a finding here, they'll have to go in and grade it, but they don't have to do it daily like they were doing. For all of our project, we'll give you calculations for unpaved roads. Like I said, we're going to give you a written summary, the calculations, cross sections, a plan to do if necessary. Whether it's free of charge, no matter what the size, we're still going to provide the same amount of support. It's based on tire pressures, it's based on the load, whether we're having geotextiles underneath it. And we also, like I mentioned before, we're going to check these mechanical junctions for factors of safety for peel, shear, and separation, but also the internal junctions. So the seams, the welds, we want to make sure that's a very high factor of safety, because that's your main failure point in any geocell. It's not the walls, it's the seams. It's the seam could pull apart. So we want to make sure those are very high factors of safety. We can also look at your project as far as the number of passes. So we use the modified version of the Geruhant formula for that, where we can look at what is your unreinforced section without, say, GEOWEB and geosynthetics, or with it. So we can show you how we got to increase the cross section depth based on the number of passes. I have this chart, and it's a pretty well accepted chart in the whole geosynthetic industry. And it looks at a lot of times you don't have the money to do a full soil report or soils investigation. So I have this chart available by email. I also have it laminated, so if you're interested, we can get you a copy. But basically, I get a lot of calls every day. Hey, I got a really bad site, but I don't have any soil boring or any DCPs or bowl counts or anything like that, but I'm walking it and I'm sinking, say, 2 to 3 inches. Then I can correlate that from a field ID to an assumed CBR and shear strength to be able to go ahead and design acceptable cross section. And I would say it's about 50% of the time we don't have any soils information in this chart. We're going to be a little bit more conservative, but like I said, sometimes you don't have the time or the money to go ahead and do a very expensive geotech report. So if you're interested, then I have a copy. So we can all, this is we're talking now about some paved roads. And this was a project, was a Union Pacific project out in the Bay Area. They're doing a big intermodal yard expansion, and the original design was for basically some grids and some high quality aggregate. They got out there, this is what they ran into: bay mud. Very, very low subgrade strength. And what was happening is, as that high water tide would come up, it would just basically just flood this site. So they were having a ton of problems getting proof rolling and everything like that. So they came to us, and so we did a lot of work with them, engineer and contractor. We did a valued engineering solution. Again, for that one here, we used, once again, that high strength enhanced woven geosynthetic. We rolled that down. This one was about 4,800 pounds per foot again. We also included a 6-inch open graded base layer beneath the web. What that was for is to basically allow the water to freely flow underneath the pavement. As that tide would come up, the water is basically free flowing in that area. And we use that same material to infill the GEOWEB. So staging, very important. We want to make sure that the contractor is all ready to go into the site. We typically do teams meetings a couple of weeks at least before the construction to make sure we have any questions, if you have all the tips and tricks to install it very efficiently and very quickly. Each panel, this one about 270 square feet, so it goes down very big, very fast. Install rates of over 3,000 square feet an hour with typically 2 to 3 guys. So it goes down very, very fast. Usually we're going to be way out ahead installing the GEOWEB versus installing the infill. Here you can say just that grader pushing that open graded type material. This one had about 5%. I think they kept it about 5 to 7% fines, but basically just infilling that GEOWEB. The GEOWEB cells itself provide the confinement, so you don't need fines in the GEOWEB for confinement and stabilization. And also, you don't need any type of special, asphalt equipment or anywhere. You're basically just going to compact that final surface and run the typical asphalt machine and roller on top of it. And this one had this was a 4-inch asphalt surface over the top of the GEOWEB system. But once again, the value engineering solution was the main driver in this. We've done, I think, 5 different expansions on this port in the last going on probably 12 years now. So we're well over probably 60 acres already. So a very successful project. Here's a project we did. This was for a small municipality in Ohio. They were originally going to do a full improvement of this roadway. It's a single-lane highway or a 2-lane highway through the small town. And what happened is they wanted to make sure that they couldn't have this road down for very long, because what happened is these businesses would see hardly any business, everything would go around it. So the engineer came to us after they encountered some very high utility conflicts, like some water and sewer lines were way up high. So the system that they're actually going to do wasn't going to work. So this is about 250,000 square feet in this small town. And they came to us, like I said, when they encountered those conflicts. So we worked with them, came up with a system, once again, with a high strength woven geotextile, 6 inches of web. They put a 2-inch surface over the top of it, and then 9 inches of asphalt. You can see the quality of the aggregate. It's not a very high quality aggregate, it's sort of a sandy crushed aggregate again. But this saved a lot of time, because if they had to excavate, they would have had to excavate and replace sewer and water lines that were not that far replaced. So here you can see one of the great benefits of GEOWEB, because this project also wanted to use lime stabilization. So if they encounter, if they put down the lime stabilization, you had any wet weather, they had to wait for it to cure. So this would have been also a delay. So with the GEOWEB, once it's infilled, you got basically a working surface. You don't have to wait for any like cement stabilization or lime stabilization any time to harden up. And you can actually asphalt right behind it. You can see here, there's asphalting right on top of that GEOWEB system. and they're still going to roll this one out and put the GEOWEB down, but they're asphalting right away. For these type of hard surface pavements, whether it's concrete or asphalt, we follow the ASTRO method. We'll work with you. We use, like all other geosynthetics, we use improvement factors to layer coefficients based on research and testing. So once we get a design structural number based on the number of passes, the type of road it is, to separate CBR and the serviceability, we can go ahead and design that road very quickly, very efficiently. We can show you how it compares to a traditional solution too, so you can actually calculate how much money you'd be saving. So in summary, we'll work with you to provide anything on any type of load support applications, whether it's under a final surface, asphalt or concrete, or an unpaved road. Like I said, very flexible in type of infill. We can use low quality sandy acres. We can use open graded material. Like this project, you can see up close. This is 100% open graded. Where they want to get a lot of water flowing through this. We'll help you. We'll provide that full, complete solution. With the type of geotextile. If you need a sub-base, type of geocell, type and depth, we'll provide all of that free of charge. Usually about if it's not a very complex problem, usually within one or 2 days, we can get that full evaluation back to you. So a little bit on some slope and channel applications. We've done significant amount of testing on the Colorado State Hydraulics Lab out in Fort Collins under the direction of Dr. Chris Thornton. We looked at indoor and outdoor testing. We've done it for vegetated aggregate and concrete fills. So first one I want to talk about is vegetated. So here you can see we just want to simulate typical installation. We used a 6-inch deep geo panel, filled it with topsoil. This was a NAG C350 TRM over the top of it. What we're trying to do here is to see how much GEOWEB improves the performance of a vegetated surface, whether ECB or TRM. So we did a total of 10 1-hour tests in the outside flume. And here you can see the performance. So here we did 10 tests, 1 hour. We had peak velocities over 30, shear stretches, 16 PSF, and 0 topsoil loss. Look at how fast the water is going down. We had some significant velocity, but those test results showed that here you can see a GEOWEB with a TRM. Here's shear in blue and velocity in yellow. You can see compared to like a 12-inch riprap, we can more than double the performance of a riprap system, a 12-inch riprap, using a GEOWEB and a TRM, because that GEOWEB confines the roots once it's established. It really prevents any topsoil loss. Once again, here's the TRM alone. And we went from 15 without the GEOWEB to double the performance. So significant amount of improvement. Go through a couple of projects for vegetated. This is a slope project we did. This is down in the Pan American Highway down in Peru. You can see the significant slopes. They get a lot of water that run down these channels here. So basically this is an old mine site, mine reclamation, that we had to provide these steep, 4 8-meter high terraces. They're up to about 75 degrees. You can see how steep they are as they're installing the GEOWEB. So what we're doing is we're trying to keep that water and the vegetation loss. We did put some here too, just to get a little riprap to slow down the water that's flowing down the channel. You can see how steep those channels are. Just like hanging a set of drapes on these steep channels, you have polyester, polypropylene, or sometimes even Kevlar tendons that run down through the panels. We have a pipe deadman buried at the crest of the slope, and we have those attra tendon clips that tie into the tendon in the GEOWEB. Basically, just to transfer the weight from the panel up to the top of the slope. And here you can see the final project. This was taken about 1.5 years after the GEOWEB was installed. So you can see a significant strength and adds to the lots of vegetation. This is really, I just love this project. This is out in Las Vegas, north of the Strip. There's a pretty nice subdivision right here on the left side of the slide. Vegas doesn't get a lot of rain, a lot of precipitation, but when it does, it usually comes down pretty intense. It can last for a long time. You can see there's a lot of erosion in this area. The city and one of the engineers, they wanted to basically improve this. Everything they tried just got scoured away. They were looking at maybe using some avian baskets, but when the homeowner saw what they looked like in the subdivision, they weren't too interested. They contacted us to do a value engineer solution. Here you can see what we did. We used GEOWEB tool topsoil, put down erosion control blankets, and hydroseed erosion control blanket. We turn this area basically into a park. So, like I said, this area will get water. A significant amount of water runs down this small little channel right here, but GEOWEB is strong enough to hold it in place along with the erosion control blanket. So, next application, I want to talk about some for aggregate infill. We did two different types of testing on this one. We did inside flume. We tested, the difference diameter sizes, the 20, 30, and 40D. We changed the slopes a little bit. We also changed the rock size. And what the main intent of this testing was to develop a riprap reduction calculation. So if it's confined in GEOWEB, how much can we reduce the riprap to what size? So we ran the tests inside. You can see, once again, they were our tests. After the testing, they would look at the rock loss and under different velocities. We sort of maxed out that testing. So we went to the outdoor flume and ran more testing. We had 5 tests and a fixed slope of 17%. And we varied that flow up to about 125 CFS. And we got, once again, changed the rock size a little bit. Like I said, our whole intent was to develop that riprap reduction problem. If you look closely here, you can actually see the water flowing over the rock-filled GEOWEB. So it basically just, the confinement prevents the scour out of the GEOWEB. So max velocities, over 18, shears up to 16, but we can reduce the rock size up to a factor of 10, depending on what your bed slope is and your flow rate. So if you have we're seeing it all over. Riprap is getting very expensive. It's hard to transport. It's hard to work with. So if you have a project where, even small projects like bridge, scupper, things where you got to place 12-inch riprap, or, we can typically do it with a 1-inch rock inside of a GEOWEB. So if you have any projects like that, we'd be more than happy to help you. But here's our here's our model we came up with. So basically all I need is the slope, the bed slope here, and the flow rate and the width of the channel, and I can evaluate that very quickly and give you some different options. We can look at different slopes, bed slopes, different flow rates. So here's a project we did out in Gila Rivers, south of Phoenix. They're getting they don't get a lot of rain in Phoenix either. When they get it, same as it comes down hard, and it was leading to a lot of problems along this 1-mile stretch of this channel. The channel was actually used as a way for people, the indigenous members, to go through this area. So they needed something that they could use as a channel, and also something that could use an access area. So we worked with the engineer to come up with different types. We ran the rock loss calculation for many types of different flow rates, different bed slopes, and we kept running. We came up with all these different solutions here. You see we had different stations numbers. We all had we ran probably 50 different evaluations for this project, just to make sure that we have a system that's going to work. So we have different types of rock on this one too, but here you can just see the channel going in. Panels together. We did put a non-woven geotextile under this one, just to prevent any scour from underneath the geo panels. Here you can see the final channel right here, and they're using it as a haul road or to run their ATVs or anything up through the tribal area. And you can see they're even using it as a fill. So once the geo is filled in, you're basically using it as a haul road for the trucks. So it's actually acting as a channel and also a load support. There are many ways to fill the panel. I mean, you can, this one, you can just dump it, use an excavator. A lot of projects recently are using rock slingers, very Easy way to go. It goes pretty fast. So we can work with you on that. Concrete surface. The last part of it is a concrete surface. So once again, we went out to Colorado State. We did the testing. This one was a 3-inch GEOWEB. We had a fixed slope of 2 to 1. On this one, we reached velocities over 36 feet per second, shears over 21. The issue with this one is that we maxed the flume out. And at that time, we're the only geosynthetic to ever max the flume out at Colorado State University. So we do a lot of concrete channels, a lot of concrete bridge abutments. You know, the good thing about concrete filled GEOWEB is the cells act as the reinforcement and also the formwork. So you can completely eliminate all that portion of your work. A lot of projects we work on are wage rate projects. If you imagine if you can eliminate the cost of the formwork and the rebar placement and tying, that's a significant benefit and savings to your project. And this is extremely strong as far as like pull-out strength. We've tested it. It's extremely strong. If you're interested, I got some of that information. This is a very interesting project we did. This was for one of the same engineers on a port project. This was a project down in Texas. The original design was for a 6-inch concrete channel here and a 4-inch grout bags on these slopes here. This is a significant size, 1.5 million square feet of GEOWEB. But the problem is the bids came in and they were significantly overpriced, over cost because of all the amount of cost and time to install not only the grout bags, but also the time to install and tie all the rebar and all the formwork for this channel that basically went around this hole in the mold area. So they called us. We worked with them on a V solution and different alternatives. We ended up with a 4-inch GEOWEB in the channel and a 3-inch GEOWEB on the slopes. We cut the amount of concrete down a couple inches in the channel and 1 inch on the slopes. That's saving a lot of money. But also more importantly to the railroad here on this one is that, you know, for them, time is money. So we actually saved a couple months of getting this intermodal yard up and into operation. So we saved a significant amount of that. Here you can see the extent of the sections being filled. Here you can see no problems with joints. You see it stop and you can keep pouring. See that before they started the concrete channel up above. You can see for just an up close picture of that. And actually, when they install this, you basically roll it right, just screed it right to the top of the panel. You don't want to do any overfilling because that's not reinforced, so it's going to crack. So you are going to see a little bit of the GEOWEB sometimes of the cells because that provides the reinforcement. And here you can just see the channels that go all the way around this yard. You can see the GEOWEB before it's placed. Once again, 3-inch GEOWEB on the slopes, 4-inch GEOWEB in the channels, going all the way around. Here you can see it's very flexible. The panels before they're filled, they don't have any strength because it's just plastic. So it's easy to cut around any type of pipe penetrations. This one, of course, is just a concrete coming into that channel. You can see we did put down a non-woven geotextile. We want to make sure when we do any concrete GEOWEB, we want to make sure that pore pressure doesn't build up underneath it, because water can fail any concrete. It's almost impossible to stop pore pressure buildup. So we got to account for it, whether that's with wheat poles spaced across the surface. We've also used pressure relief valves in channels and tanks. Where we allow the water to basically flow up into the channel so it doesn't build up to pore pressure. So we'll also work with you on that portion of it too. We do a lot of concrete channels, just the same philosophy with that last time. We do a lot of channels for the Bureau Rec. These are all drainage channels out in Colorado getting the water down. We wouldn't want to lose the water. So they want something fast and easy that they can pretty much just use on any type of surface or any type of slope. So what they've basically settled on is we put down a liner here, a textured liner, 4-inch GEOWEB or 6-inch GEOWEB, depending on the slope angles. Here you can see a really good picture of how this pipe dead man, the tendons are just attached to it. going down through the entertaining clips. It's hard to see those, but basically just supporting it like a set of drapes over the slope. We don't want to lose the water. They want to make sure that as much water as possible can be maintained and transferred from up high to down below. Here you can see another picture. The dead man pouring the GEOWEB, screening it right to the top. And this is the final channel. See a final channel on that. You can, like I said, you can see some of that. We build miles and miles of these for the Bureau Rec out in Colorado. I think we use that testing based on Colorado State. Make sure the velocities, but these velocities never really get that high. If you do have a really high velocities, what we want to do then is we actually can design in some basically baffles to actually slow the water down. So we call them energy dissipation baffles. But if you have an area where say this is a channel coming to an end at a higher velocity, you don't want to transfer that scour from a channel to an open area. We can actually design in some energy dissipators here to stop that velocity, really slow it down so that it gets off the channel. It's not going anywhere and cause high scour. So we can also help you on that. So in summary, again, it's very flexible for slopes and channels. We can fill it with topsoil, aggregate, concrete. It's all backed by research we did at Colorado State. Any type of challenging applications, we've seen them all from mine sites with 45-degree slopes where we had to add energy dissipation to really challenging projects. So we'll give you a complete solution with anchors, tendons, plans, cross sections. If you need a geotextile, we also can provide the research summaries. We have 1-2-page research summaries, independent from CSUs. So we can give you the limitations of the system and advantages too. So that's what I want to talk about is earth stabilization. We could actually do a bunch of different types. We can do reinforced slopes. We can do gravity walls. We can do MSE walls. We can do different types of applications for earth retention. We can do steep slopes a little better, or we can do slopes down to 20 degrees. So this is a pretty cool project we were involved in. This was I think a 30 to 40 day rainstorm out in Hawaii at Wheeler Air Force Base. They had at the Army base, and then what happened, they had 6 or 7 landslides that happened. So all the service roads, they lost a lot of their service roads. A lot of debris coming down. They had avalanches. They had even lava flows. So it was just terrible. So they had a lot of issues they had to deal with. So the Army Corps got involved, and they went out with the design build project. The initial design was basically cast in place concrete walls on micropiles. Then they got a shotcrete wall with another concrete drive slab. They had drilled shafts, steel H beams, precast concrete panels. I mean, you name it. It was a very, very hardy system. But what happened is, once again, they went to bid, and the costs were significant. One of the biggest reasons was because of difficult site access. It was hard to get the construction equipment and the equipment needed to install all that the concrete H or the steel H beams, the shafts, all that. It was very expensive to get it up there, and almost impossible. So the winning design team approached us, and along with the engineer, and they had done a bunch of GEOWEB walls before, so they brought that as an advantage. So we worked with them. And basically, the biggest one was easy construction and be able to get the equipment into the site to work on it. So whenever we're looking at structures, the typical, when we're doing designs, we're going to make sure we look at groundwater, whether there's dry season, wet season. We want to make sure that there's no indication of deep-seated failures. We're going to use soil values if we have them available. Most of the time, as people that design walls, you're really sort of guessing at these walls. We didn't have geotech information available on this, so we assumed some conservative values here. And those are all based on the determining for this one, because it was an MSE wall, so we had to design the geogrid tieback. And for any geogrid wall, we follow FHWA requirements that usually it's about 70% of the wall height and embedment depth. And that's sort of a rule of thumb that most engineers use to design reinforced or MSE walls. So you can see them just preparing that base slab. They start put on their first part of the GEOWEB after they prepared the system. Here you can see typical construction is we have one panel is about 8.67 feet. And what we do is we have these stretcher frames. So you put the geocell or geo on the stretcher frame when it's flipped over, and you flip it over and attach it with the keys here. And then as you fill it, you just pull these stretcher frames and go on to the next system. Just continue that all the way down the wall. It's very easy to install. That's why a lot of these walls are just built by landscape contractors. It doesn't have to be a general contractor. It can, but it doesn't have to be, because it's really not that difficult to install them. Here you can just see the uniaxial geogrid that's getting ready to be placed, and there's a couple of geo panels laying here. When you infill these and compact these, you want to make sure that you don't hammer compact the cells, especially on walls, because what happens is you can actually raise this panel a little bit, which would lead to a loss of infill from these geocells. So what you want to make sure is you just lightly compact these cells. The good thing here too is we can fill the front fascia with topsoil and have a vegetated wall. We can fill it with aggregate. We can fill it with concrete if it's along a river bank or a stream bank that's going to see excessive flows. So we can fill with all different types of material. This one, they actually used a 50-50 topsoil aggregate blend. So they knew how much grass grows in Hawaii, that they want to provide some structure to it. So they actually used basically a 50-50 blend of aggregate and topsoil. Here you can see the finished wall. Not a problem with any type of penetrations. We had some sonotubes that went down below this wall, so there's no problems with any pipe penetrations going. I'm just going to just cut it to allow the sonotubes for installation. So if you do design walls and reinforced slopes, we have a free software. It's called MSE. It was designed by Adam Engineering. Very easy to use. Like I said, you can gravity reinforced walls. It comes with training guides. We have thousands and thousands of copies of this software being used. The good thing about it is, it can do all the different types of analysis. A lot of engineers use it because within 5 minutes you can design a wall. So they'll look at it and say, is a GEOWEB wall or a reinforced slope possible? They use this software, say yes it is, or no it isn't. Then they want a more detailed analysis, like reslope or RESA, or it's one of those. They can use those programs more in depth. So this, like I said, this is for free. If you're interested in a copy, you can go to our website at prestogeo.com, and under the design tab, you can request a license, or you can just contact us. You can send me an email. I'll show you that. We're coming up soon, a couple more slides. You can reach out to me and I can send you the software. It comes on an annual basis. So I'll send you a password and the software at the end of the year. I have to send new copies out because we upgrade the software every year. So the password remains the same unless you get a new computer. But I need to send you a new copy. So in summary, same flexible system. We can do reinforced slopes. We can do gravity walls. We can do reinforced walls. We can fill that front cell with topsoil and vegetate it. We can do an aggregate, concrete. We have that free software. Once again, we're going to give you a free complete solution. It's going to be a written summary. We're going to run the MSE for you, MSEW. We're going to get the full design. It'll show you the geogrid strength, the uniaxial geogrid strength that you need to basically stabilize these walls. This is a picture that is a wall in Ohio. By a zoo in Ohio, you can see here, they did fill it with topsoil. This picture was taken in early fall, I think sometime early November. This picture was taken the following summer. So a lot of our walls are vegetated, so you won't even see them. So that's what a green wall looks like after about, say, 6 months of vegetation. So we recognize that every project is unique. It really does depend. Need a unique, specific site evaluation. So we'll make sure that we work with you. And as I mentioned earlier, I know we're not going to be the right system for every single project. If that's not That's not going to happen. We're going to hook it with our local distribution network. They're not only work, versed in GeoWebs, but also in geosynthetic solutions. So we'll let you know right away if GeoWeb is a good solution, or we have to send you over to our distributor, and then we can work with other manufacturers and get a more cost-effective solution. So this is our standard specification. 40 years we've been doing this. All the different ASTM, we follow ASTM and ISO test methods. We're ISO certified. We always follow this spec to a T. We're always constantly, research and testing these values, so we know that when the material comes to the job site, it's going to meet the spec. So we have a very detailed website at prestogeo.com, as I mentioned. All these different tabs from products, applications, the design tab, installation, a learning tab. Here's the learning. We have all kinds of pre-recorded webinars on there. So if you're an engineer, you got to get PDH certs. You can sign up on our learning tab, and you can take as many webinars as you want. It automatically creates a PDH for you. You can store it. So if you 2 years comes and the state contacts you and says, hey, I need your PDH certs, you can go to our website and get them. You can also, if you want a free project evaluation, you just click on this tab right here. That brings you to the next page, and you just fill out all this information. It comes to our engineering team, and within a day or two, we're gonna get back to you with a full evaluation recommendation, or we'll contact you right away, talk about it. And if we have any questions or concerns, you can attach PDH or PDFs to this. You can attach CAD drawings. So if you have, any type of soil geotech reports or, CAD drawings, cross sections, whatever, you can attach it here. Usually we'll get these right away, and usually within a day for sure, we're going to get back to you with something. So we made it, like I said, we made it faster and easier on those PDHs. So if you sign up on our webinar and that dashboard, like I said, you can go, this is what the dashboard looks like. It'll have your name, it'll have all your webinars, it'll have once you completed, here's all your certificates. So it'll all be on our dashboard, our webinar dashboard, if you sign up under the learning tab. Now you won't find the on-demand, like the live webinars. They're managed separately. It goes through, go to webinar, but within the next 24 hours, you should get an email and go to webinar that has a link to obtain your PDH cert. If you don't get that, check your spam. But after 2-3 days, if you don't got it, just shoot me an email and we can create one for you. So like I said, all these learning tabs, you're going to have the webinar, the dashboard, but not the on-demand, the live webinars. So a little different way of tracking them. So I want to thank you for attending. I went through a lot of stuff fast. So if you are interested in more information, please let me know. Here is my email address, my first name dot last name at prestogeo.com. Here's my contact number. That's my cell number. So text me, email me, however you're going to get in contact me. And like I said, we'll try to work up a V solution that does work. And I'll mention again, if we're not the right solution, we're going to get somebody else involved. So with that, I got left some time for questions. On a retaining wall can exposed sidewall be covered with rock or other finish? Yes. Yep. So we can, a lot of times we'll put riprap on the bottom of these walls, just to protect it from some scour. What happens if vegetation goes dormant in the winter when we have erosion? That's a good question. No, because what we'll do is we size the erosion control blanket, or we'll size a TRM, or we'll make sure that we work with our distribution network. We've got a good experience in erosion control blankets and TRMs and solutions, but we're going to work with the experts and those manufacturers to make sure that whatever we recommend is going to get scoured away. Another good question: if we use it in road construction, how do we come back and repair it? Yeah, it's just like any other geosynthetic. What most people do, is they use a concrete saw or pipe saw. A lot of contractors will just go there and excavate down to the top of the GeoWeb and take a pipe saw and just cut it. and do your pipe repair or any kind of repair underneath it, and then just get some more geotextiles on the GEOWEB and just piecemeal it right back in. So it's really pretty simple. Have you used geocells and cofferdams? Yes, we have used GEOWEB for installation of pipelines under cofferdams. We've also used it on a lot of sanitary and storm sewers for differential settlement, especially under concrete ones. For a residential situation, yep. Yeah, well, I mean, our engineering team just did a small 200 square foot 200 square foot project this morning that they sent out evaluation to a homeowner. So not a problem. Yeah, they've been using high speed rail. Yes, they have. One of our biggest areas is rail. Whether it's Australia, Network Rail, or all the class ones here in the States, Canada. Like I said, I'm on those REMA committees, so we've been very active in rail intermodal yards. So yes. Can we use GEOWEB for the spillway of a big residential pond? Yes. Yeah, all we just need is the slope, that information. We can design it for you. Go back to some of the original. So we have a steep slope instead of creating a tall retaining wall. I'd like to provide short retaining wall. Yeah, so if you have a steep slope, they don't want to do a really tall retaining wall. A lot of times what we do is we'll use tiered walls. So we can use smaller rises, and we'll step back the walls because that geogrid gets at 70% tieback length to height. That can get pretty excessive if you do one tall wall. And other times we'll do maybe a couple tiered walls, and we use a slope on top of it. Usually on top of a slope, we want to limit the wall angle to about a 2-to-1 or about 26 degrees. But yeah, absolutely. Any condition that geotextile fabric on the base will be unnecessary. Yes. Yes. If this infill material of the base is the same as in the GEOWEB, yeah, you don't need a geotextile. Some of our concrete applications, they don't put in either. It's because they I want to just basically save the money if it's not going to be wet when they're pouring the concrete. Airfield applications, yes, we've done pull-off areas in the grass. We've done the runout areas at the end of airfields. We've done Cleveland Hopkins. We did a really cool de-icing pad where they used the GEOWEB for the de-icing fluid. So yeah, we've done airfields before. I get to a different one. What is the minimum channel depth can be used in? Can be flat. A lot of the channels we do are foot deep. Some of them we've also known them that are 30 feet deep too. So yeah, there's no really minimum or maximum channel width or depth that we can use for the GEOWEB. And we'll a lot of times we'll run the egg calc first, and then you can see what it looks like. So sometimes you can use egg grit, sometimes you can create, sometimes you can use topsoil vegetation. So we'll give you all the different applications for. And another one on the utility trenches repairs. Yeah, it's very simple. Soil stabilization, vegetation growth, or flatter surface GEOWEB typically used in tandem with hydroseeding or sod. Run typically actually. It's all based on what type of flow you're going to see over top of it. Hydroseeding now, with all the different tackifiers they're coming out with now, I would say at least 50% of our projects are hydroseeded. Very, very few are sod. We actually use GEOWEB for temporary storage or parking areas where they fill it with 2/3 aggregate and 1/3 topsoil, like say churches and sporting events. I've had a couple of those where they use sod because they want to use it right away, but yeah, sod typically not. That's more into our porous pavement type of systems. You have special GEOWEB system using. Well, we do landfills all the time. We're doing. I think this summer we'll probably end up doing about 5 million square feet of landfill covers all over the U.S. and all over the world actually. Because the biggest thing, usually we anchor the GEOWEB right into the liner trench. One thing on landfills, covering it with anything is slippery. If you ever walked up a smooth liner in a landfill, you know how angles can get pretty slick. So we usually recommend a textured liner because that really keeps the requirements for the anchor trench down. But usually we can put our anchor trench right into liner anchor trench. What factors lead to the decision between 4 and 6 inch for Geocell on paved road? Subgauge strength and the weight of the vehicle, and number of passes. So if it's light vehicles, you know, like cars, trucks, maybe ASHTO H10 delivery type vehicles, those are usually going to be a 4 inch. But like I said, we do those evaluations for you free. If you just shoot me an email and say, hey, I got this road, like subgrade strength is X, I'm this Y vehicles, and I want 1,000 passes or 1,000,000 passes, we can run that evaluation for you for free. So this be used in high velocity zones to prevent coastal erosion, implemented into sand dunes. Well, yeah, we've actually used it in sand dunes before. So yeah, that was one of the first things we started using it when we started selling it commercially was some sand dune restoration of some areas. But yeah, and just if you're interested, shoot me an email. We can take a look at it. I think that's pretty much all of them. How do you? Oh, here's another one. How do you prevent differential settlement for trench repair restoration? Assuming you've heard. That's where the geosynthetic, that enhanced woven geotextile, and the geo really play together. You know, that enhanced geotextile will vary the strength of that. You know, starts at 2,800 pounds per foot, can go up to well over 10,000. The incremental price difference is not that significant. So what we'll do on those applications, we'll size the strength of that geosynthetic based on what type of pipe, whether it's a concrete pipe, PVC pipe, how big it is, how much it weighs. So we'll take that into consideration. So we really want to make that, once we compact that GeoWeb on top of the geotextile, really want to make sure that geotextile gets into full tension. So yeah, that's a great question, but it really does work in tandem. Two very, very good products that really work together to help differential settlement. And we use it not only for differential settlement in pipe repairs, but usually all of our intermodal yards, our ports, our roads, anything they're working together to prevent that differential settlement, potholing, and things like that. So yeah, great question. All right, I think that's about it. So I guess with that, once again, thank you very much. If you have any questions, once again, here's my contact information. Just reach out and more than happy to help you. Have a great rest of your day.